Determining empirical formula. The empirical formula of a compound gives the simplest whole number ratio of atoms present in a compound. So in this little table here, we have 4 different compounds. First one's butane, and the molecular formula for butane is C4H10. This is probably how we're used to seeing something like butane presented as C4H10. But that is its molecular formula, it's not its empirical formula. The empirical formula, again, in the definition says it's the simplest whole number ratio of atoms present. So I'm going to underline that because that's the important part here. It's the simplest whole number ratio of the atoms present. Let's go back down to butane and think. C4H10. So what does this mean? It means in one compound of butane, there's 4 carbon atoms and 10 hydrogen atoms. Now that is not the simplest ratio of carbons to hydrogens. And the way that we can think about that is if I move over to the side here, C4H10, what we can do is we're actually able to think about that as 4 carbons to every 10 hydrogens. And this is now the ratio that we have, and this can actually be made more simple, okay? And we can do that by maybe dividing the whole thing by 2. If I divide this whole thing by 2, the ratio becomes 2 is to 5. And we now can think about it as for every 2 carbons, there's 5 hydrogens. This can't be divided down any further. Okay, this can't be divided down any further. If you divided that down any further, say by 2 again, we would arrive at a ratio of 1 is to 2.5. Now, okay, well, why does that not work? Because if we go back up the top, our definition of empirical formula is the simplest whole number ratio. And 2.5 is not a whole number. So we need to remove this. That is not how we can think about butane as an empirical formula. So what's the empirical formula of butane then? Well, over here we worked out that the simplest ratio is 2 carbons to every 5 hydrogens. So I'll go back over to my little box. I'll write it in as C2H5. And there's the correct empirical formula for butane. Let's have a look at a second example, ethane. So let me just change pen colors here. Ethane, its molecular formula is C2H6. So I'll work down here, C2H6. So that means for every 2 carbons, there's 6 hydrogens. Now, is this the simplest whole number ratio of carbons to hydrogens? No, it's not. What I'm actually able to do is I can divide. I'm just going to redo that a little bit more to the left. I can divide by 2 and divide 2 by 2 will equal 1 and divide 6 by 2 will equal 3. And I've kept my whole numbers, I haven't gone to decimal places, and therefore I was able to make a more simple whole number ratio. Can this be divided down any further? No, it can't, not without getting to decimals. So the empirical formula for ethane is CH3. Let's have a look at ethene. Okay, well, let's not do any of this working out anymore. Let's see if we can jump straight there. It's 2 carbons to every 4 hydrogens. So can this be made any more simple? Yes, it can. We can divide the number of carbons by 2. We can divide the number of hydrogens by 4. And that would give ethene an empirical formula of CH2. Let's have a look at pentane. So the molecular formula for pentane is C5H12. So can this ratio of 5 carbons to 12 hydrogens be made any more simple? As long as we're keeping the whole numbers. No, it actually can't. There's no number that I can divide 5 by and 12 by. That's going to keep, well, it's going to give me an answer in whole numbers. So the empirical formula for pentane is going to be equal to its molecular formula. Alright, so something interesting to note there, that the molecular formula and the empirical formula don't always have to be different. Okay, we can see in this example here, it has actually kept exactly the same.